Welcome to video number 1. This is our review for lessons 1 through 8, and it will probably come in 4 different parts. I'm just making short videos rather than trying to get through a long one as I'm learning this as well. So, why is it sad that parallel lines have so much in common? That would be all right, let's get into question number 1 here. This video is mostly for tips and tricks, not the solutions. So just a reminder that all horizontal lines are going to be y equals equations, because the y is constant. The x is what's changing. There's no change in y. All vertical lines are going to be x equals equations, because x never changes. There's no change in x, just y. All right, so putting in x equals -3 would be a vertical line. All right, translations. Just remember with translations that 0, 0 to 4, 1 is going to be from 0, 0 to 4, 1, and that all your other lines are kind of be like parallel to that, so you're just kind of making that whole parallel line process to translate points. You can also translate the original coordinates. All right, don't forget that y equals x. You can also do that. That would be y equals x right here, and y equals -x right there. So you can reflect over any line, it just depends. But those are the 4 kind of basic ones. Also with the translation on the coordinates right there. Oops. 0, 0 to 4, 1. Really, that's just right 4 and up 1 for all the coordinates. All right, so good luck with that one. Next up, we got the sequence of transformations. A good idea on these ones is that translating the line up to a corresponding vertex is best. So what you usually want to do is translate your line, or one of your vertex, up to itself. So like you could translate right here, straight across from B to B prime, and then at that point, you'd just be either rotating or reflecting the line. Looks like that one's going to actually reflect across the x-axis once you rotate it. So there's the hint there. And then moving on down to the next one. Prove. Don't forget, prove means use transformations. So use transformation descriptions to prove. Same thing as the problem above. You got rotations, reflections, and translations. All right, next up, we are going to be translating. Let's see, this is almost like the very first problem, so kind of same as the very first one. Translating and reflecting. Just draw your lines correctly, vertical and horizontal. You can use the directed line segments as parallel lines to translate, like we did off the grid, or you can just go, what is that one? Right 3, up 2, all right? You can also write out all the coordinates as well if you want to show coordinate translations. Okay, number 5. Let's see what we got here. We got some matching. All right, should be self-explanatory, but just remember, when you get x plus something and y plus something, you got a translation. When you've got switching signs, you've usually got a reflection. When you've got switching variables, like y switching to x and so forth, you've usually got rotation, and that may be combined with sign changes as well. Like -yx, that's going to be rotation. And then dilations, it's just that constant scale factor, kx, ky. That will be a constant scale factor, so it has to be constant, same k. So K equals San Francisco, a place you can't visit right now. But that's about it. All right, so with that, go ahead and watch the video. I'll have another one coming up here pretty soon, and then try them on your own. Solutions will be coming in a few days. Good deal. Have fun, folks.